So students, moving to the next topic of chapter 3, and this is very important, one of the most frequently asked questions, and this is Ohm's law. Actually, this is a very fundamental of this fundamental topic of this chapter, Ohm's law. So this law talks about electric current and potential difference. This law says if we apply a potential difference V across a wire, then the current flowing through it is directly proportional to the potential difference applied across this conductor. It means if we double the potential difference, then the current will be doubled. We halve the potential difference, current will also get halved. It means the potential difference and current are directly proportional to each other. But provided, actually this is not a universal law, because this law is not compulsory for everything to follow, because conductors, in most of the cases this law is followed by conductors. In insulator there is no case of insulator because there is no current. Semiconductor does not follow this rule. This law is followed by conductor, and still all conductors don't follow this law in all conditions. There are certain conditions for everything. So this is not a universal law, but for most of the conductors and for in natural conditions, this law is quite followed by metals. So this law tells if the physical conditions of the conductor remain same. This is the very first constraint of this law. This law is obeyed only when the conductor is applied in the conductor is used and the physical conditions of the conductor remain same. And what are those physical conditions? Number 1, the length of the conductor, cross-sectional area of the conductor, temperature of the conductor, and material of the conductor. It means the conductor must be same with the same temperature. The conductor must be same. Itself says the length is same, the cross-sectional area is same, material is same. It means this conductor is same, and additionally at same temperature. This must be same in all the cases, and keeping these all things same, if we vary potential difference, then current will also be varied with the same proportion as the potential difference. So these two are directly proportional. So just a simple statement, and this statement says if the physical conditions remain same, then the current flowing through the conductor is directly proportional to the potential difference across its ends. If this is a conductor applied through a cell and the potential difference across the ends of the cell is V, then the same potential difference is also across the conductor, that is V, and the current flows through it is I. So I is directly proportional to V, or we can say V is directly proportional to I, and proportionality constant R is taken here, so V becomes IR. By graph, directly proportional, if X and Y is directly proportional to X, and we plot X and Y on a graph, so this gives a straight line. Y equals to mx plus c, a general equation for straight line. So if this angle is theta, then the slope of this graph tells tan theta, and tan theta is nothing but V upon I, and from here V upon I is nothing but R. And friends, R is a very important quantity of this chapter. I must say R is the key point of this chapter. And now we are starting with the term R. R is a constant known as the resistance of the conductor used. R is the resistance of the same conductor at that particular conductor, that particular wire used. It's not that like that ki you have taken the wire of copper and for all copper wires the resistance are same. No, this is not at all. Not at all this is the case, because that particular conductor is of a specific length, of a specific cross-sectional area, on a specific temperature. So these must be same with the material. Then the resistance will be specified for that conductor. So R is a constant known as resistance of the conductor used, and resistance, now we are starting with the definition of the resistance, and friends, this become R equals to V upon I. This is mathematical denotion of resistance. So conceptually, resistance is just the behavior of a conductor by virtue of which it opposes the current. Every material has a behavior that it opposes the current flowing through itself. So resistance, it is the property of the substance by virtue of which it opposes the flow of current is known as resistance. Resistance conceptually is nothing but just the property. Greater the resistance of a material, lower the conductivity, or worse the material as a conductor. Smaller the resistance of the conductor, better the conductivity or better conductor that material is. So resistance is property by virtue of it opposes the flow of current, and this is a scalar quantity. I have left to write it as a scalar quantity. So remember, resistance is a scalar quantity and R equals to V upon I. So here we must say that the unit for resistance is what? Volt per ampere, and in standard, international standard, volt per ampere is also known as ohm, OHM, ohm. So unit of resistance will be ohm, and the dimension for resistance you can easily figure it out from potential upon ampere, and this will become mL2 T minus 3 A minus 2. So scalar quantity, unit and dimension are these. Resistance depends on. Now students, a question may be asked like this: define 1 ohm. Yeah, define unit resistance. So 1 ohm resistance is what? If I take V as 1 volt and current as 1 ampere, 1 volt and 1 ampere. So 1 upon 1 is 1, resistance will be 1 ohm. So I am giving the statement of 1 ohm resistance. 1 ohm resistance or unit resistance is that resistance of a material, of a conductor, which gives, into which 1 ampere current flows upon application of potential difference of unit voltage or 1 volt. Upon applying 1 volt, it means, in other words, upon applying 1 volt, if a conductor gives 1 ampere current, then the resistance of that conductor is said to be 1 ohm. So resistance depends on. Resistance is not a constant for a given material. Resistance depends on the length of the material. Greater the length, greater the resistance. It means resistance directly varies with length. So number 1, length of the conductor. Resistance depends on length of the conductor. R is proportional to L. Number 2, resistance inversely varies with area of cross section. Thicker the wire, if I make this wire thicker, then the resistance of this wire drops. So resistance inversely vary 1 upon A. R is proportional to 1 upon A. If I combine these two statements, then this will give R is proportional to L upon A, and here the proportionality constant is rho. R equals to rho L upon A, and rho itself here is an important topic, important quantity. Rho is known as specific resistance or resistivity of the material. Rho is specific resistance. Now I am going to define rho. I am not writing because I have to rub this board. Otherwise, you hear it carefully and write it down on paper. So I am defining rho. If L is 1 meter, A is 1 meter square, then 1 upon 1 becomes 1. R will become equal to rho. So resistivity of a material, it is that value of resistance when that taken material is of unit length or 1 meter length and unit area of cross section. If I am taking a material, a conductor of 1 meter length and 1 meter square cross section, then the resistance of that material, of that conductor, the resistance of that conductor, what conductor? 1 meter length and 1 meter square cross section area. The resistance of that particular configuration of particular structure of conductor, two things, 1 meter length and 1 meter square cross sectional area, the resistance of that conductor is equal to the resistivity of the given material. Now listen carefully, resistivity of the given material, it means resistivity is a property of that material of the conductor. I can say the resistivity of copper is a constant at normal temperatures. Resistivity of aluminum is a constant. So resistivity of conductors are constant, but resistance is not a constant for a material. Rather, resistance is a constant for a conductor at for that configuration at that particular temperature. If I change anything, be it its length, its cross sectional area, its material, its temperature, the resistance will be changed. So resistance is not a constant, rather resistivity is a constant for that material.